Our purpose today is to apply inferential statistics. So what we will do is to answer this problem. Is there a significant difference between the mean score or the mean content of COLAs given to the pupils during the outreach activity and its label 8 ohms? This can also be stated in objective form, stating that the objective of this study, or the objective, is to compare the mean content of COLAs with the content claimed by COLAs company. So in answering this problem, we're going to follow the hypothesis testing. So first, we need to state the HONHA, or the null hypothesis and alternative hypothesis. The null hypothesis states that there is no significant difference between the mean content of COLAs given to the pupils during the outreach activity and its label. While the alternative hypothesis is that there is a significant difference between the mean content of COLAs given to the pupils during the outreach activity and its label. Okay, so this is the alternative hypothesis and our null hypothesis. So for step 2, we will state the level of significance. So in the case of this example, let's set it into 0.05 or 5%. So what is the step 3? Step 3 is to determine now what is the possible test for this problem. So since we are comparing one sample mean, and that is the sample of mean content of COLAs with the standard 8 ohms, that is the population mean, so which means possible test is one sample t-test or one sample Wilcoxon test. So for us to determine what is the appropriate test for our data, we need to check for the normality of the data, or if it satisfied the assumption for us to use the test. So let's conduct the preliminary assessment. Okay, so first, let's check the nature of the data. So the data is at least interval, then it is possible to use parametric test. One sample t-test is the parametric test, but another condition that we need to consider is that if it is normally distributed. So let us check what is the nature of the data. So this is the data. So obviously we are talking about the content, so it is being measured. So this is 7.3 ohms, 7.8 ohms, 6 ohms, and all other values here. So which means it is at least interval. So for the first assumption, so let us check it. How about for the second assumption? So how will we determine if the data is normal or not? In our previous lesson, we discussed that we have several ways to check the normality of the data. We can actually use descriptive statistics, like using the computation of the mean, the median, and the mode, comparing the values. We can also use histogram. We can also use the computation of the skewness and kurtosis. But aside from that, let us consider another way to check for normality using an inferential test called one sample Kolmogorov-Smirnov test. And in doing the computation, we are going to use online calculator. So what is the website for this online calculator? So this is the one sample Kolmogorov-Smirnov test of normality. So let us just show that. So what is the website? Let us enter the website here. So it is www.soc sci-statistics.com/test/kolmogorov/default.aspx. So using this, we can just copy our data. So from the encoded data in the Microsoft Excel, I'll copy this in the website. Control V to copy your data. Control C, Control V to paste it. And then simply we have here calculate, so just click calculate. So it will present you distribution summary, so the count, the mean, the median, standard deviation, skewness, and kurtosis, but our concern is of course the result. The K-test statistics is 0.25 or 0.26, which means that the p-value here is 0.22663 or 0.23, indicating that the data is normally distributed, as also again indicated in our interpretation generated from this website. So your data does not differ significantly from that which is normally distributed. Therefore, our data is normally distributed. So let us just reflect it in our preliminary analysis. So we considered the nature of the data. And of course, part of it is the purpose of the data. So the purpose is to compare one sample to population sample. So that is checked. Another is the data is ratio and it is normally distributed with the value of one sample KS, which is 0.23. So let us place it here. Or if not, let us reflect 0.22663. So this means that the data is normally distributed. Therefore, since we satisfy the condition, then obviously we can use one sample, our one sample t-test. So next, we will generate the result. So just like using 1KS using our online calculator, we will also do that for us to compute for one sample t-test. So where will we enter our data now? So in quick statistics, we can find also here the t-test for one sample or t-test calculator for a single sample. So let us check that. So you can find for other information about t-test for one sample here that the data is normally distributed. So we are done checking for the normality of the data, that it should be at this interval. So if we will use the manual computation or manual formula, so we will just substitute the value in this equation, but we're not going to compute it manually. We're going to use the online calculator. So just click that. So what is the population mean? That is the 8 ohms. And for the sample mean, all we need to do is just to copy again our data set. So where is our data set? So Control C, and let's go back to our this one. So significant difference 0.05, and what type of hypothesis did we consider? So it is two-tailed. Then click calculate. And then let's see what is the result. So the t value is negative 2.29. The value of p is 0.037. The result is significant at p less than 0.05. Okay, so let's go back to our data. Step 4, generate the result. So to generate the result, we will just simply copy that the t-value is negative 2.29. So we will just simply copy this. And decision, so the result is significant at p less than 0.05, which means that we are rejecting the null hypothesis because based from the generated result using the online calculator, there is a significant difference, so we are accepting the alternative hypothesis, which means we are rejecting the null hypothesis. So there is a significant difference between the mean content of colas given to the pupils during the outreach activity and its label 8 ohms. So for the interpretation, I also included here a table that will show also the value of the mean, the value of the SD, and the computed value negative 0.294. So just to have an idea of how we computed for this value, you can go back to your table and just simply type is equal sign average. So this is for the mean. And then for the SD, so standard deviation for sample, this one. Again, just select your data until 6. So 0.89. So going back to our table, so these are the values, 7.47. So we just copied it here, 0.90. So we round off our values into 2 decimal places. T-value is generated using the online calculator. So it's negative 2.29. And degree of freedom, so to compute for the degree of freedom, this is equal to the number of sample minus 1. So let us place it here. So the formula for degree of freedom is equal to n minus 1. So in the case of our example, we have 15 samples minus 1 is equal to 14. The degree of freedom is equal to 14. So p-value or the sig value is also generated using the online calculator. It is 0.03778. So let us just reflect this. 0.038. So we round off to 3 decimal places. Mean difference, so you can just deduct 8 minus 7.47. So that's, or it's negative because 7.47 less 8. So it's negative 0.53. So what is the interpretation of this? So let's go back to our data. So this means that, so let's just show the interpretation. So as gleaned in table 1, the mean content of colas given to the pupils during the outreach program was 7.47 ohms. This mean content was lower than the content label in the colas bottle. Moreover, the one sample t-test result shows that there is a significant, or there was a significant difference between the sample mean content and the ounce colas label. This indicates that the colas given to the pupils were significantly lower than 8 ounce. This further means that the colas given did not pass the quality control of the colas company. Thus, the colas were donated instead of bringing back to the company. So that's the example for one sample t-test. So in another video, let us also try another different inferential statistics. Thank you for listening.